For this lesson, let's talk about scientific notation. Scientific notation is when you're made to use extremely giant, right? Your huge numbers and extremely tiny numbers, right? Giant, like when you talk about the weight of the planet, right? Things that are huge numbers. Small when you're talking about the size of an oxygen molecule, right? Things that we can't even deal with numbers that big, like in a real life kind of sense. It's more like a theoretical on how huge and small numbers can exist, but how we can write them. It's usually written in the form of a times 10 to an n power, where a is a number that's bigger than or equal to 1, but less than 10. So expect a number that's between 1 and 10. We'll talk about when it is 1, but the n is your exponent, an integer, and it's basically how many times you move the decimal is how you really want to think about this one. Now, the key takeaways are to turn this number into a times 10 to the n. You would first say, all right, well, I've got my number that's between 1 and 10. So I'm going to put my decimal here, 3.25. And then I would end up counting how many times did I move this decimal? 1, 2, 3, 4, 5, 6. Now, when I say 6 times, what we really want to think about is this being positive is what means my huge number. Because think of what 10 to the 6th power means. 10 to the 6th power means 10 times 10 times 10 times 10 times 10, right? 6 times, which means 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Those numbers get huge fast. So even though 6 seems like a small number, when it's 10 times itself that many times, that's why that's such a huge number. And where that also means is when you see that positive number, well, then that's what I would say. All right, well, I need to make this number bigger. So move it 1, 2, 3, 4, 5, 6. That's where you would end up filling that same one. Now, when we're talking about really small numbers, you're going to notice here that again, the 4. So my decimal is going to be after the 4, 4.7. And then I would look at, well, how many times did I move this decimal? 1, 2, 3, 4, 5 times 10 to. But what we want to think about now is that has to be a -5, because when you have that negative exponent, that's when you're talking about tiny numbers, itty bitty numbers, right? The numbers that are the size of an oxygen molecule, right? The width of a piece of paper, something that's so small, it theoretically, we can't even deal with it. The negative exponent. Now, what we want to think about is whenever you have a positive exponent, that's huge. Whenever you have a negative exponent, that's tiny. Because think about what the negative exponent means. Negative exponents would be divide by 10 to the 5th, which means divide by 10, divide by 10, divide by 10, divide by 10. When you're dividing a number by 10 that many times, that's what's making it smaller. Divide by 10, divide by 10, divide by 10. That's what your negative exponent is doing. But in short, the major takeaways are when you got the positive exponent, that's huge. When you got the negative exponent, that's tiny. This number in front is always between 1 and 10 times 10 to whatever power, however many places you move that decimal.